In this video, we will discuss equations of lines. All right, we've already done all of our graphing, looking at linear functions, looking at domain and range. What I want to do now is be able to, if I give you certain characteristics of a line, I want you to be able to create an equation of that line. All right, we've already discussed how to do this when we're given us an equation in slope-intercept form, right? Y equals mx plus b, right? Remember, m is your slope, and b is your y-intercept. And I'll abbreviate that with int. So remember, if we're given a slope and a y-intercept, we can use this equation right here very easily to come up with the equation of a line. In all other cases, what I'm going to do is I'm going to use a different form of the equation of a line, and it's called the point-slope form of the equation of a line. It's y minus y1 equals m times x minus x1. All right, again, our m is still our slope, but notice here I have a y1 here and an x1 here. That is a point, right? If you notice, I'm given a point and a slope in order to write the equation of this line, and so x1, y1 is going to be a point that the line goes through. All right. One thing to note when we write equations of lines, whether we're using y equals mx plus b or this equation here, our final result, we're always going to write it in y equals mx plus b form. So even if I start with point slope form, my final answer is going to be put in y equals mx plus b form. So at the end, when I look at this type of equation here, all I have to do is solve for y. And the reason why we're going to do that is because normally when we graph, one of the easiest ways to graph is to use the slope and the y-intercept. And so that's what we'll do here. Let's look at an example where we use this equation of a line. All right, it says find the equation of the line with slope -5/3 that passes through the point 3, -1. And what we're going to do is we're going to leave our final answer in slope-intercept form. That means y equals mx plus b. All right. Well, in this example here, they give us that our slope is -5/3, and we're given my point that the line goes through is 3, -1. So that tells me that m for that formula is -5/3, and my x1, y1 is 3, -1, right? And remember, that equation of a line is y minus y1 equals m times x minus x1. And so what I'm going to do is put -5/3 in for m, put 3 in for x1, and put -1 in for y1. And so we get the equation y minus a -1 equals -5/3 times x minus 3, right? That's x1. All right, for me to solve that equation, or solve it for y, so I've used the formula for the equation of a line, which is right here. Now it's time for me to solve for y. Well, when I subtract the -1, that's the same thing as adding 1. And I'm going to distribute this -5/3. I get -5/3 x, and a negative times a negative is a positive. And when I multiply the 5/3 by the 3's cancel, and we get a 5. All right. For me to finish solving for y, I subtract 1 from both sides, and that way I get y equals -5/3 x plus 4. And so this is the equation of the line with slope -5/3 that passes through the point 3, -1. Let's look at other examples. In the example that we're about to look at, we're going to find an equation of a line when I just give you 2 points that that line passes through. So instead of like in the last example when we gave you the slope and one of the points, now I'm going to give you 2 points. Well, the difference here is, remember, when we use our formula y minus y1 equals m times x minus x1, we need a slope and a point. Well, here I'm giving you 2 points, and specifically in this example, it says find the equation of a line that passes through the points -2, 9, and 4, -3. And then, as always, we're going to write our equation in slope-intercept form. Well, I have a point, but I don't have the slope. So the first thing that I'm going to want to do here when I see these types of problems where we give you 2 points is use the 2 points to help us find the slope. After we find the slope, we're going to use the slope and one of the points to write the equation. And so this is where you have to remember the formula for slope. y2 minus y1 over x2 minus x1. And so I'm going to call this first point x1, y1, and the second point x2, y2. And so that gives me my 2 points. And so if I put it into my slope formula, I get negative 3 minus 9 over 4 minus a negative 2. If I continue here, I get negative 12 over a positive 6, which tells me that my slope is negative 2. And so now I have that my slope is negative 2, and my point that I have, x1, y1, I'm going to use the point that I've labeled x1, y1, the point negative 2. That's a positive 9. I'm sorry. All right. Now, just for your information, you actually can use the other point. You don't have to use the point that you label x1, y1. As long as it's a point that the line goes through, it is perfectly fine. All right. What I'm going to do now is I'm going to put that information into that equation of a line there. And so I'm going to get y minus 9 equals my slope, which is negative 2, times x minus a negative 2. All right. Have my equation of my line. My next goal is to solve for y. Minus a negative 2 is a positive 2. And if I distribute that negative 2 to the x into that positive 2, I get a negative 2x minus 4. The last thing that I need to do in order for me to solve for y to get it in slope-intercept form is to add 9 to both sides. And I'll get that y equals negative 2x plus 5. So this is the equation that passes through the points negative 2, 9, and 4, negative 3. And one way for you to check is just plug those points, plug these 2 points right here into your original equation, or the equation that you developed, y equals negative 2x plus 5, and you will see that those 2 points actually do work for that equation of the line. All right. The last type of situation that we're going to look at dealing with coming up with an equation of a line is, let's say that I give you a line and ask you to come up with an equation of a line that's parallel or perpendicular to that given line that passes through a certain point. That is what we want to do next. All right. Well, first, if we're going to do that, we want to first find the slope of the given equation, right? So I'm going to give you a line. First, find the slope, because if you want to create a line that's going to be parallel or perpendicular to that, well, you're going to have to be able to know what the slope of that line is, right? And once you find the slope, if you're asked to create a line that's parallel to that line, well, the slope of the new line that you're going to create is going to have the same slope. All right, if it's going to be perpendicular, then the slope will be the negative reciprocal, just as we've talked about before. Once we know the slope of the new line, we'll always give you a point. Then you can use the slope and the point to write the equation of the line. All right, and so we're going to look at this example, which says find the equation of a line that is parallel to the line y equals 2/5 x minus 9 and passes through the point 5, 4. All right, and so in this example, what we're going to do is I first have to look at the line that I'm given, right? I'm given this line right here, y equals 2/5 x minus 9. The slope of this line, right, it's already written in y equals mx plus b form, so the slope of that line is 2/5. All right, since I want to find an equation that is going to be parallel to that line, the information for my new line that I'm going to create is going to have the same slope, right? Because parallel means same slope. So the slope of my new line is also going to be 2/5. All right. Remember, we're coming up with an equation of a line. Y minus y1 equals m times x minus x1. We already have our m, which is perfect, but we want to be able to also have our x1, y1. And in the given problem, it tells us that we're going to find the equation of a line that's parallel to this line that passes through this point right here. And this point is the point 5, 4. And so now that we have all of this information, I'll put it in here. So I get y minus 4 equals 2/5 times x minus 5. Of course, we're going to want to solve for y. So I'm going to use my distributive property here. Distribute that 2/5 to the x, we get 2/5 x. Distribute it to that negative 5, we get a negative 2. Last but not least, we'll add 4 to both sides. And when I add 4 to both sides, I'll get that y equals 2/5 x plus 2. All right, and that is the equation that is going to be parallel to this given line up here. And we know that it is parallel because it goes through, all right, it has a slope of 2/5. And it passes through the point 5, 4, right? If we plug in 5 for x right here, Notice the 5's are canceled. We get 2 plus 2, which is 4. So we have satisfied everything that we needed to create that equation of the line. In this example, this last example we're going to look at, I want to go through the same process, a similar process, but this time I want to create a line that's perpendicular to this given line here and passes through the point 6, negative 2. All right, for me to do that, I've first got to find the equation of this line here, right? I'm going to have m equals the slope of that line is 2/5. So if I want information about my new line and knowing that it's going to be perpendicular to that line with the slope of 2/5, well, the slope of this new line is going to be negative 5/2. And I've gotten that because it's the negative reciprocal of 2/5. All right. They give me that my line that I'm going to create has to go through the point 6, negative 2. And I've got all the information that I need to create my equation of my new line here. All right, and so remember the equation of a line that we use is y minus y1 equals m times x minus x1. And so I'm going to plug in negative 2 for y1, 2/5, sorry, not 2/5, right? My slope of my new line is negative 5/2. So I get negative 5/2 times x minus x1, which is 6. Well, that'll be a y plus 2. And I distribute my negative 5/2. And when I distribute it to the negative 6, that'll be a positive 30/2, which is 15. Last but not least, we'll subtract 2 from both sides. And we get y equals negative 5/2 x plus 13. Okay? And so what we see here is that, hey, this has a slope that is the negative reciprocal of this line here. And if you plug in 6, which is our x coordinate here, that'll give you a negative 30/2, which is negative 15. And if I add 13 to that, I'll get the y coordinate, which is negative 2. So we've satisfied everything that we've needed in order to create that perpendicular line that passes through that point. And this concludes this video.